Hi, Mrs. LaJoy here. Today we're going to look at quadratic relations like we did previously and steps to find the zeros. So first of all, I want to refresh your memory here that standard form of a quadratic relation looks like this. Y equals ax squared plus bx plus c. And from this quadratic equation, this quadratic relation, the c term is our y-intercept. So if we have to identify our y-intercept, for example, if we have this equation, y equals 7x squared plus 2x minus 5. What is my y-intercept? Right here. Y-intercept is negative 5. What about with the example y equals 11x squared minus 6x minus 15. What is my y-intercept? Right here. Y-intercept is negative 15. Another example, y equals x squared plus 13x plus 4. The y-intercept is right here. The y-intercept is 4, positive 4. And y equals negative 6x squared plus 10x minus 8. Again, you guessed it right here, y-intercept is negative 8. So whatever the c term is in our relation is our y-intercept. So now we're going to look at finding the x-intercepts. Remember, we call the x-intercepts our zeros. So the second thing, like I just said, is to find the x-intercepts. Remember, these are called our zeros. So in order to find them, we have a couple of steps. So the first step is going to be to change the equation from standard form into factored form. So we have to, let's use an example here. So step 1, if I have y equals x squared minus 8x minus 33. I need two numbers that will multiply to give me negative 33 and add to give me negative 8. Well, those two numbers are going to be negative 11 and positive 3. So that would be y equals x minus 11 and x plus 3. So that's factored form, right? So the first thing to do was to change it from standard form to factored form. Our second step is going to be to set our y equal to 0. So step 2, set y equal to 0. So this was step 1 here. So step 2 is going to be 0 equals x minus 11, x plus 3. The third step is going to be to solve for x. So I'm going to write over here 3, solve for x. So step 3, what I'm going to do is for each of these, I'm going to set my y is equal to 0. So I have x minus 11 equals 0. That's one part of it. The other part is going to be right here. X plus 3 equals 0. So what do I get here? I want to isolate for my x's, okay? So x equals, if I have a negative 11 here and I move it to the other side, it becomes a positive 11, right? So x equals 11. Over here, if I move my positive 3 to the other side, it becomes a negative 3. So that means my zeros are 11 and negative 3. So therefore, the zeros are, now remember we have to write these as coordinates. So the y is always going to be 0. So if my x is 11 and my y is 0, that coordinate is 11, 0. And the other one is at negative 3 and 0. Remember, this is an x and a y and an x and a y. So if I was to graph this quadratic equation, which is y equals x squared minus 8x minus 33, the two places where this parabola would cross the x-axis, remember we have a graph like this, and this is my y-axis and my x-axis. One of them would be crossing at positive 11 and 0, so let's say that's up here. And one of them would be crossing at negative 3 and 0. So somewhere, right about here. So those are the 2 points where it will cross the y-axis. The x-axis. So those are our zeros. Let's do another example. So our next equation that we'll look at is y equals 2x squared plus 6x minus 80. Now this one's a little bit different because the x squared has a coefficient that's greater than 1. So what we have to do here is factor this like we would normally factor, like we did in our polynomials unit. So we have to pull out our greatest common factor. And our greatest common factor here between these three terms, 2x squared, positive 6x, and negative 80, our greatest common factor is going to be 2. So if we pull 2 out, remember we're going to put our leftovers in brackets. We're going to divide everything here by 2 and see what we have left over. So what do I have left over if I divide 2x squared divided by 2? I'm left with x squared. 6x divided by 2 is going to give me a positive 3x. And negative 80 divided by 2 is going to be negative 40. So we're partway there now because we have, this is like where we started the last question with what we have in brackets. We had this extra 2 we had to take out. So now we need to factor what's left in the brackets. So let's factor this. X squared plus 3x minus 40. What are two numbers that will multiply to give me my last term, my negative 40, and add to give me positive 3? Well, the only numbers that will work here would be 10 and -4. So my factored form here is going to be x plus 10 and x minus 4. So all of this here was step 1, right? Step 2 was to set y equal to 0. So for step 2, y is going to equal 0. So we're going to say 0 equals 2 times x plus 10, x minus 4. Step 3 was to isolate my x, right? So for this one here, I'm going to say x plus 10 equals 0. And for this one here, I'm going to say x minus 4 equals 0. So I have to, again, isolate my x, right? So this 10, this positive 10, if it moves to the other side, becomes a -10. This -4, when it moves to the other side, it becomes a +4. So there are my x's. So therefore, the zeros are, so again, if we're writing this as a coordinate of where the parabola is passing through the x-axis, one point it's going to pass at is at -10 and 0, and +4 and 0. Remember, I'm doing this because these are our x's, and the y is always going to be 0. So those are the 2 points where this parabola will pass the x-axis. What we'll do is y equals 3x squared minus 12. So again, we need to, our first step is to factor. So we need to take out our greatest common factor. The greatest common factor between 3 and 12 is going to be 3. So if I take 3 out and I divide what we have left by 3, let's figure out what our leftovers are. So 3x squared divided by 3 is just going to be x squared. And -12 divided by 3 is going to be -4. So now I have to factor this, right? This is a difference of squares in the bracket. So to do this difference of squares, we have x minus 2, x plus 2, right? One bracket is x minus 2, one bracket is x plus 2. So step 2 was to set my equation equal to 0. So I have 0 equals 3 times x minus 2, x plus 2. And step 3 was to isolate our x's. So if I have x minus 2 equals 0, and x plus 2 equals 0, and I isolate here, move this -2 to the other side, it becomes a +2. On this side, I move my +2 to the other side, it becomes a -2. So there are my zeros. This parabola will cross the x-axis at +2 and -2. So those coordinates would be, so therefore, the point of intersection, or the zeros are 2 and 0, and -2 and and 0. And you've probably noticed by now that once we get our quadratic relation here into factored form, our zeros are going to be the opposite of what our factored form is. So if you notice that we had x minus 2 and x plus 2, our zeros ended up being the opposite. This negative 2, our 0 was a positive 2, and this positive 2, our 0 was a negative 2. So you may eventually be able to kind of cut out step 3, because you'll realize that once you have it factored, it's going to be the opposite of what you have in your brackets. If you have a negative 2 in your bracket, your 0 is a positive 2. If you have a positive 2 in your bracket, your 0 is a negative 2. All right? The second part of this lesson, I want to go over with you the different kind of features of the quadratic relation so you can identify them. And I'm going to give you this handout, but I also just want to walk you through it so you can use this then as a resource. So we are using the example of y equals x squared minus 4x plus 3. So that's our quadratic. So the first thing we want to be able to do is to look for the c value, because that, remember, is our y-intercept. So remember that we just did this. That plus 3 at the end of the quadratic, that's our c value. So therefore that is our y-intercept. So y-intercept equals 3. So at positive 3 is where this parabola will cross the y-axis. Now to find where this parabola crosses the x-axis, we have to find our zeros, which is what we just did previously. So in order to do that, we have to factor. So in the case of this equation, we have, again, y equals x squared minus 4x plus 3. So I need two numbers that will multiply to give me positive 3 and add to give me negative 4. So those two numbers are negative 1 and negative 3. So I write this in factored form. Remember, that was my first step, to factor it. My second step was to set it equal to 0. So I changed my y into a 0. And then my third step was to solve for each of the x's. So if I have x minus 1 equals 0, and I rearrange this, I get x equals 1. If I have x minus 3 equals 0, and I rearrange it, I get x equals 3. So therefore my x-intercepts, or my zeros, are at 1 and 3. So that is where this parabola will cross over the x-axis at positive 1 and positive 3. Now the next feature of the quadratic relation is our axis of symmetry. Now remember that the axis of symmetry is kind of like that line that cuts right through the center of the parabola. And we can think of it like a mirror. It goes right through the center, and both sides look the same, like a mirror image. So if we have these two x-intercepts, it's going to cut right through the middle of these two x-intercepts. So the way we figure that out is to take our x-intercept values and add them and then divide them by 2. So if I have one of my values is 1 and the other value is 3, I'm going to add them together and divide by 2. So 1 plus 3 is 4, divided by 2 equals 2. So therefore the axis of symmetry, or the AOS, is at x equals 2. That line that cuts that parabola right in half runs right through positive 2 on the x-axis. Now the next part here is to look at our vertex. So remember, the vertex is going to be the highest or lowest point that the parabola reaches. So if it is a parabola that opens downward, it looks like a mountain when we graph it. It has a high point. If we have a parabola that opens upward, it's kind of like a valley, right? It goes down into a valley and it reaches a low point. So what we have to do in order to find our vertex is we're going to substitute the x value from the axis of symmetry into the equation and then find our y. So I'm going to take that x value, remember we just figured that out here. Our axis of symmetry was at positive 2. So I'm going to let my x equal positive 2. And I'm going to plug it into the equation. So y equals x squared minus 4x plus 3. I'm going to make all of those x's 2. Okay, so y equals 2 squared minus 4 times 2 plus 3. Now I need to work those out. So 2 squared is 4. And then I have negative 4 times 2 gives me a negative 8. And of course I have my plus 3. So when I work that out, 4 minus 8 is negative 4, plus 3 is negative 1. So if my y equals negative 1 and my x was 2, that means my vertex is at negative 1 and 2. So my y-intercept of my vertex is negative 1. My x-intercept is 2. Now remember, the next thing here is to look at the direction of the opening. So if it opens looking upward, that means my A is going to be positive. If it opens downward, it's a negative. So this example here, we know that from our equation we had x squared. It was a positive. That means it opens upward. You can kind of think about it like a smile. Like this looks like a smile, right? It's like a valley. It reaches that low point, but it looks like a smile. So it's positive. It's opening upwards. So just by looking at our equation, we know this is going to open upward because it's a positive number. If we had a negative x squared, it would open the opposite way. It would go downward because it would be negative. Okay. Now the next thing is that the maximum value, if the parabola opens downward and it forms kind of a mountain, it's reaching a maximum point. And we would say it has a maximum value of whatever the vertex is. Now this one here, because this one opens upward and it reaches a low point, it has a minimum value. So the minimum value is going to be the same as whatever our y value of our vertex was. So since our y value of our vertex was a negative 1, the lowest point this reaches is at negative 1. So our minimum value is negative 1. And then if we bring it all together and graph it, this is what it would look like. Okay, we have our vertex plotted right here at negative 1 and 2. We have our 2 zeros. We have our y-intercept. And then we have the dotted line running straight through to show our axis of symmetry. Okay, there's more examples here. So another example, we can go through it a little bit more quickly. So this one here, we have y equals negative 2x squared plus 8. So we know that our c value is that plus 8. So our y-intercept is at plus 8. Our zeros, again, we have to take this and factor it. So we pull out our greatest common factor, which is a negative 2. And what am I left with in my bracket? X squared minus 4. I have to factor that. So this is a difference of squares, right? So what two numbers am I going to multiply to give me that negative 4? Well, I got negative 2 and positive 2. So my factored form is going to be y equals negative 2, bracket x minus 2, x minus 2. And we know that our x-intercepts, or our zeros, are going to be the opposite of what we have in those brackets. So that means my zeros are going to be positive 2 and negative 2. Okay, the axis of symmetry, again, we have to take our two zeros, our two x values there, and add them together and divide by 2. So I have positive 2 plus negative 2 divided by 2. So positive 2 plus negative 2 gives me 0, divided by 2 is 0. So that means our axis of symmetry is going to be right in the center of this graph, right at 0. The vertex, remember, I'm going to take whatever my axis of symmetry was, that 0 that we ended up with, and we're going to plug that in for x in the question. So let x equal 0, and we plug this back into our original question, so all my x's become zeros. So I end up with y equals negative 2 times 0 squared plus 8. Well, 0 squared is 0, and 0 times negative 2 is 0. So I end up with 0 plus 8. So y equals 8. That means my vertex, the highest point of this parabola, is at 0 and 8. What direction does this open? Well, we go back to the question and look. Because it's a negative 2x squared, that means that this opens downward. So we get like this mountain or a frowny face. It opens downward with a frown. And because it reaches a high point, we have a maximum value. So the highest point that this reaches is at positive 8. So we have a maximum value of 8. So if we graph this, this is what it would look like. We have our two zeros at positive 2 and negative 2. We have the vertex at 0 and 8. And then we draw the direction of our opening to show that this opens downward. Okay. Last example on this handout, we have y equals 2x squared minus 4x minus 6. So really quickly, again, our c value is going to be what our y-intercept is. So because our c value here is, let's move that down a bit, because our c value here is negative 6, that means y equals negative 6. Our zeros we have to factor, so pull out the greatest common factor, which in this case is a 2. So I am left with, my leftovers here are x squared minus 2x minus 3. So then I have to factor what I have left. Two numbers that multiply to give me negative 3 and add to give me negative 2. Those are going to be negative 3 and positive 1. So my factored form ends up being 2 bracket x minus 3 x plus 1. When I set those to equal 0 and I figure out what my zeros are, I end up with x equals 3 and x equals negative 1. Remember, it's going to end up being the opposite of what I had in the bracket of factored form. So there's my zeros at positive 3 and negative 1. To find the axis of symmetry, I'm going to take those zeros, add them together, and divide by 2. So 3 plus negative 1 divided by 2. 3 plus negative 1 is 2, divided by 2 is 1. So our axis of symmetry is going to be at positive 1. That's, remember, that line that runs straight through the parabola. My vertex, in order to find the vertex, I'm going to take that axis of symmetry, which was 1, and substitute it in for x in the original question. So I have let x equal 1, and I put 1 in for my x's. So y equals 2 times 1 squared minus 4 times 1 minus 6. And let's figure out what x is. Well, 1 squared is going to be 1 times 2 is 2. And then -4 times 1 gives me -4. And then we have our -6. So we're left with 2 minus 4 minus 6. 2 minus 4 minus 6 ends up giving us a -8. That means the vertex is going to be at 1 and -8. This parabola is positive, right? Because we have 2x squared. It's not a negative, so that means it opens upward. Again, kind of looks like a smile, right? So our direction of opening is up. And remember the minimum value, minimum or maximum. So if it opened downward, we'd have a maximum value. Because it opens upward, we have a minimum value. That minimum value is at -8. So then when we graph it, this is what it would look like. We graph our zeros, our 2 points where it's going to cross the x-axis. We graph our y-intercept, where it crosses the y-axis. We graph our vertex right down here at the low point or the minimum of this parabola. And we draw our dotted line right through the center on the axis of symmetry.